Hello, I'm Paul Beckwith, and in my previous video I talked about the nonlinear physics behind the AMOC, the Atlantic Meridional Overturning Circulation, and how looking at early warning signs, for example, a critical increase in the variance of the signal, the fluctuations in the both extremes, up and down, and also a critical slowing down of the frequency response, so a loss of resilience of the system. Both of those factors show that the AMOC is approaching the point of a shutdown. This nonlinear physics in this peer-reviewed paper, which just came out, and it's been making headline news across the world, and I discussed it in great detail in my last video, is arguing that the probability of the AMOC shutting down is between, is 95% for the time period 2025 to 2095, with a mean of about 2050 or between 2050 and 2055. So this is very, very significant because the Intergovernmental Panel on Climate Change argued that it was a very, very small probability, much less than 10% of this occurring before 2100. So clearly we have a huge problem, and the AMOC shutting down, the AMOC tipping, is basically, it's the mother of all tipping elements in the climate system, because many, many other tipping elements are connected to the AMOC. And that's not the case for many of the other tipping points, like loss of Arctic sea ice, huge glacier loss from Greenland, collapse of the Amazon rainforest, permafrost thaw with huge outbursts of methane. Things like that are all, threats to the climate system and humanity, but the AMOC, the ocean circulation, is connecting pretty much all of those. So if the AMOC shuts off, it's a huge deal. I can't think of any other single thing in the climate system that would not have as much disruption as this. So I want to go into some more of the details. So first of all, we know that the equator's warm, the poles are cold. Heat transfers from the equator to the poles, both the North Pole and the South Pole, via the atmosphere and the oceans. About a third of the heat is transferred by the oceans and ocean currents, and about 2/3 in the atmosphere. And because of the rotation of the Earth, and things rotate to the right in the northern hemisphere due to the Coriolis force, and to the left in the southern hemisphere, we get the atmospheric configurations of the jet streams and the ocean current patterns set up. Now, what's fundamentally an issue is that there's a global warming hole, if you like, south of Greenland, which has been quite persistent. So it doesn't matter what metric that you look at, but the ocean is actually warming much, much slower in that region than anywhere else on the planet. And in fact, it's actually cooling. It's shown cooling over time in that period, and that's correlated with very, very warm water off the eastern coast of the US occurring simultaneously. And both of those things, the cooling south of Greenland in the ocean and the warming off of the east coast of the US, are good indications that the AMOC is slowing down. So there's a lot of correlation to the strength, the water flow in the AMOC. And basically think of the Gulf Stream, surface water moving northwards, northeast off the eastern coast of the US, then crossing the ocean, bringing all of this heat to Europe. And when it goes north, it cools down, and it sinks to the bottom a few kilometers, 2 to 3 kilometers, and then that cool water is a lower branch, the deeper branch of the AMOC, the ocean overturning, and then that goes all the way to Antarctica, where it rises up. The AMOC is crucial. The chimneys in the northern hemisphere, where the water descends from the surface down to the bottom, brings lots of oxygen to the deep ocean, and the rise of the water from the abyss up to the surface in the southern hemisphere, just northwards of Antarctica, brings lots of nutrients there, which is very important for the Antarctic being a huge sink of carbon, because those nutrients going to the surface cause phytoplankton blooms, which absorbs tremendous amounts of CO2. Okay, so we've got this whole conveyor system, if you like, and it's slowing down because, and this is correlated, we know, because of this, global warming hole, if you like, or cool area south of Greenland. Now, the initial papers were coming out about that global warming cool, hole or whatever, the cool area. I mean, when I was talking about it back in 2015 at the Paris Climate Conference, I remember having a discussion with Jason Box, and I said to him, yeah, well, I think obviously that cooling area is due to the AMOC slowing down, and because the warm waters piling up off the east coast of the U.S. I mean, it's pretty clear from a systems point of view that's the case. And he, looked at me with a very sort of deep, sort of put his thinking cap on, and also, then it started being talked about in the science community a bit more after that. And Stefan Ramsdorf did a lot of work and published a paper, I think in 2018, that looked at that very thing that I was talking about in 2015. So basically, we know that the AMOC is slowed down significantly. And if you look at, various metrics, if you look at sediments on the seafloor and look at isotopes, and if you look at size of sediment particles, and if you look at the all of these different things, then it's clear that the AMOC is the slowest that it's been in the last 1,000 years, at least in the last millennia. Okay, so the next question becomes, is when will this thing start tipping over, and what are the implications to the planet if the AMOC shuts off? So those are very, very key questions. And I've already said that if, the AMOC tipping or shutting off is sort of like, it's the cornerstone of the climate system, if you like. It's the mother of all tipping points, because many other elements of the climate system will tip very shortly after the AMOC tips, because it's got so much importance and it's got so much connection to the rest of the planet. So those are key factors. So when will it tip? Well, there's a number of studies that have come out recently showing, looking at the paper most recently is the nonlinear physics paper, looking at the early warning signals, the critical slowing down of frequencies, and the increase in variance of the ocean current amount or volume in sverdrups. A sverdrup is 10 to the 6 million cubic meters per second. And, we've seen a significant drop in that. It's the lowest it's been in 1,000 years. But when will it tip over? Okay, so the early warning signs can project that, it will likely happen about the 2050 time period. There's a 95% chance of it happening between 2025 and 2095. So it could happen as early as a few years from now. Low probability of that, but it is a possibility. Okay, so this is a key thing. Now, what happens to the planet when the AMOC shuts down? Okay, so that's a big question. Well, clearly the Gulf Stream carries tremendous amounts of heat to northward regions, across, it heats Western Europe. The water, it makes Britain, for example, a fairly mild climate. And if you look at the latitude and compare it to an inland place, say in North America or Asia, they're much cooler, much cooler, because you get this tremendous amount of heat. So if the AMOC shuts off, we can talk about the temperature. So most of the places in the places in the northern hemisphere get colder, and most of the places in the southern hemisphere get warmer. Okay, that's a general thing that's easy to say. So how much cooler does the northern hemisphere get with all that heat not being transferred up by the ocean current? So if you look at the high Arctic north of the Canadian archipelago, north of Greenland, down the east coast of Greenland, across, the temperatures can cool as much as 5 to 8 degrees Celsius with an AMOC shutdown. If you look at places like if you look at the east coast of the U.S., off the northeast coast of Canada, Newfoundland, and up in those regions, you can actually get a cooling of, a degree or two Celsius. If you look over at the UK, typically, 2 or 3 degrees Celsius cooler. Off the western coast of Europe, 2 to 3 degrees cooler. If you look at the Scandinavian countries and north of those countries, the water temperature, and air temperature, you can actually get about 8 degrees, up to 8 degrees Celsius cooler in those regions. So massive changes in temperature with this tipping event. And if you look in the southern hemisphere, you get warming. You can have that 2 to 3 degrees Celsius increase of warming. We get the drop in the northern hemisphere, but you get the gain of temperature off Africa, for example. South Africa, the western coast can be 2 or 3 degrees Celsius warmer in those regions. So basically, the temperature goes haywire on the planet, and also the precipitation goes haywire between 30 degrees north and 30 degrees south on the planet. So basically, you have this intertropical convergence zone where there's very high precipitation, and if the AMOC shuts down, that moves southward. So where it is now, just north of the equator, call it, say I said between 0 and 30, it is between 0 and 30 degrees north, something like 10, 15 degrees north, you get much up precipitation because the ITCZ has shifted southward. So you can get a drop of precipitation, up to 100% sort of in some regions, a huge drop of precipitation. And by the same token, if you go south of the equator, say between 0 and 30 degrees south of the equator, you get a huge increase in precipitation because the ITCZ, the Intertropical Convergence Zone, has moved southward. So you can get rainfall amounts, huge increases, over 100% and higher increases of precipitation in those regions, even higher than that. So at least a doubling of precipitation. So you get a huge temperature change and you get a huge precipitation change. So this causes the agricultural, the food growing regions of the planet to actually significantly, have lower yields. I mean, things go haywire with the AMOC shutting off, and it basically brings global food shortages and price spikes and huge problems to feed the 8 billion people on the planet. Okay, so that's a significant thing, but there's also other factors to do with sea level rise because of all these temperature changes and the circulation changes in the ocean. You get huge dynamic changes in sea level of the planet. So what happens is the sea level actually increases significantly at many places in the northern hemisphere, and the sea level drops significantly in the southern hemisphere. So talking about the southern hemisphere first, between from north of Antarctica to about the latitudes of the southern tip of South America, southern tip of Australia, you get about a 0.3 meter decrease in sea level in this region. That's about a foot. Okay, sea level drop there. That water has to go somewhere, and it ends up in the northern hemisphere. So in the northern hemisphere, if you talk about the very, very far north, sort of north of Scandinavian countries, north of the Canadian archipelago, you can have sea level increases there from anywhere from 1 to 3 meters. So 3 feet to 9 feet higher sea level rise. This is a dynamic effect. This is a fact that basically, if we get a shutdown of the AMOC, this kicks in very, very quickly because the water sloshes into these regions. The forces have all changed, the dynamic forces. So that component of sea level rise changes significantly. In areas like the Gulf of Mexico, across the ocean to the Mediterranean, you get a sea level rise of up to about 0.3 meters, which is up to about a foot of sea level rise in those regions. If you go, and there's a lot of structure in what the sea level rise is actually going to be as you go, between those two extremes, between the high north and the regions of sort of lower latitudes in the northern hemisphere, like I've mentioned, the Gulf of Mexico and the Mediterranean, about a foot. Other places are a foot and a half, 2 feet, 0.3 meters, to 0.6 meters, 0.7 meters, as you move up. So I think off the coast of, off the northern coast of Scandinavia, I think you have sea level rise there of something like, something like a meter plus, so about 4 feet. And I think off the UK, it can be a foot to 2 feet sort of thing, at those sort of latitudes. So the AMOC shutting down is a catastrophic event for humanity, and it's the probability of it happening between 2025 and 2095, just to repeat, it's a 95% probability that it will shut off in that time frame. Best guess is close to the center of that interval, but skewed a bit earlier to about between 2050, 2052, 2054, something like that time period. But there is a chance that it can occur as early as 2025, according to this nonlinear physics paper that came out recently. So this is a huge deal for the planet. It's a huge deal for people on the planet, and it's like I said, just to repeat once more, I'll probably put this in the title. The AMOC shutting off is the mother of all tipping points, because the cascading effects, hit everything else. It's really, it's hard to overstate this. I mean, this is going to be catastrophic for our climate system, for our weather patterns around the world, for the way that heat is transferred from the equator to the poles, and of course that affects where water falls on the planet. It affects, how mean temperatures of various regions across the planet, the whole planet, not just in the northern hemisphere. It affects how we grow food. It will affect everything, basically. So this is what we have to look forward to. In our climate system, we're heading through abrupt climate system change, and we're seeing all of these consequences. And you can see sort of things happening right now, because so what you can see is, for example, the jet streams have slowed down and become so much more wavier and stuck in place that we're getting persistent stickiness of them. We're getting weather extremes, increases in the frequency, severity, and duration of weather extremes. And they're also happening in places they never happened before. There's no place that is not affected on the planet. We're basically in the, I call it the climate casino. If you happen to be unlucky, then the place you live just gets nailed. There's adverse effects. So where I am in Ottawa, for example, we had massive rainfall and flooding, record flooding of the Ottawa River, flooding out a lot of people living along the river, both on the Quebec side and Ontario side. That was in 2017. In 2019, it was even worse, flooding. And we had it repeat this year. And between those two flood years, 2017, 2019, and 2018, we had massive, we had a tornado swarm, basically. Some tornadoes actually narrowly missed downtown Ottawa. We're just north and went off into Gatineau. Tornadoes, I think EF2s. There was one that went through southern Ottawa, and there was a third one. We've had a lot of different tornado warnings this summer. Just today, there was a lot of more tornado warnings. I think a tornado probably went across south of Ottawa. A year ago, just over a year ago, we had a strong derecho, which took down loads of trees. This storm today had, I've never seen, basically huge amounts of hail in certain spots of Ottawa. Fortunately, I think my neighborhood's been spared, but other neighborhoods, lots of trees down, high winds, and hail, much, golf ball size hail, even larger, up to maybe fastballs, sort of size, hail hitting regions. And I think the insurance costs are going to be very, very high on this storm. So, but in terms of the whole climate system, the North Atlantic temperatures are skyrocketing in the ocean. The temperatures in the southern hemisphere, basically the Antarctic sea ice is not growing as it should be. It's winter in the southern hemisphere. The sea ice should be growing around Antarctica, and it's setting record lows. In fact, it's 6 standard deviations below where it should be. So the odds of this happening naturally would be something like 1 in 3.5 million or something like that. So we're getting disruptions of the entire climate system, and I think we can actually explain lots of these sort of patterns by what's going on with the AMOC slowing down. That, the ocean circulation can explain a lot of these different factors. Some people are saying, it's just the El Nino, very strong El Nino. But the El Nino effects, there's some sort of lag generally between the ocean temperatures in the equatorial Pacific and the effects on us. And the El Nino is powerful. It's been ramping up, but it's too early for it to be causing all of these effects that we're seeing around the planet right now. So basically, buckle your seatbelts. The AMOC shutting down is basically the mother of all tipping points, and it will be a historic thing for humanity when it shuts down. And I'm only talking about the one study recently, but there's a whole body of evidence that seems to be saying that we're getting, we're approaching much more faster than we would have expected, than anybody would have expected towards this point where the AMOC shuts down. So thank you for listening. Please go to my website, paulbeckwith.net, and donate to support the videos like this one. And I've got well over 1,000 videos on the whole climate system. So, I like keeping my work independent. I can say whatever I want to. There's nothing holding me back. There's no institution. There's no reticence on what I say. I just say what I see, and I've studied the climate system for so many years. It's like a chess game. I recognize the patterns, and I can see what's going on. The more I read about it and the more videos I do, the more I get a deeper understanding of what's happening. So please support my research and videos by donating to PayPal on my website, paulbeckwith.net. I also have a Patreon page if you prefer that way of supporting me. And most importantly, please share my videos and talk about them with friends, etc., so more and more people understand what is going on and the dire threats that we face from abrupt climate system change, so that we can get a tipping point in human understanding of these issues, and therefore a tipping point in action to actually try to address, try to slow down, try to do what we can to try to, reduce and minimize effects, and, also look seriously at deployment of carbon dioxide removal, capture, methane reduction capture methods, and solar radiation management to basically cool the planet, to give us time to deploy some of these other things, these carbon capture things. So, the Earth energy imbalance is just unbelievable at the moment. I think I saw a number, something like 1.97 watts per square meter just recently. If you look at it, what it's done in the last few decades, it's just mind-boggling. And remember to look at James Hansen's paper, Global Warming in the Pipeline. We've seen 0.18 degrees Celsius increase per decade trends, but that seems to have shifted at about 2010, it's increased, it seems, by 50 to 100%. So from 0.18 degrees Celsius increase per decade to somewhere between 0.27 and 0.36 degrees Celsius per decade. And you can just do the math, figure out, decades ahead, and you can see what the temperatures are going to be. And you can see what the consequences we're seeing already right now, with all the breakdown of climate systems. Imagine what's going to happen when we're half a degree higher, 2 degrees higher, right? It's just, it's not that difficult to imagine some of the turmoil that we're going to be in. So please make sure that you follow me on Twitter, follow me on Facebook, Instagram. I do post to Instagram. I do quite a bit on Reddit now, on r/climate. I also post on Quorum, and I've joined Mastodon and Blue Sky, and the Threads, I guess, and I've even I got the app for Truth Social, so I might start posting my videos to the Trumpers on Truth Social as well. So I just try to get this message out as far and wide as I can, and that's how you can help me more than anything else, by sharing these videos far and wide, so I build up sort of a subscriber base. So anyway, I'm sure I'll have loads more to talk about. Some of the things I've talked about right now, I'll show you all of the substantive diagrams and research to back up what I've been saying in this video. And I'll also probably do a number of videos on the OECD report on climate tipping points. That report is it's from about a year or two ago. It's an excellent look at it's a really good way of looking at how all of the tipping points in the Earth system are related, and when one thing tips, how it might lead to cascading and further tipping of other things, like a stack of dominoes toppling over. And if you look at the diagrams in that, and I'll go over that in detail in some future video, you can see how the AMOC is sort of the mother of all tipping points, in terms of importance, it looks like to me, because it just connects to so many other ones. It's like the linchpin of the whole climate system. So thanks for listening, and please follow me in all my social media endeavors, and like I said, please consider supporting my research and videos by donating at my PayPal on paulbeckwith.net. So thank you for thanks for following me, and for listening, and please spread the word. Okay, bye for now.